Hey guys, tonight we're going to be going over how to convert or change from a repeating decimal. Oh, my pen is totally dying on me. Good timing. Repeating decimal, I'm just going to say RD, to a fraction. I'll represent that with an F. So repeating decimal to a fraction. So before we do that, I just want to refresh, because it's going to be a similar process when we do these next few problems, how to isolate a variable or how to demonstrate when you do something on one side of the equal sign, how you must do it to the other to be balancing it out, kind of like a scale. So in this first one, 60 plus z equals 100. In order to get z on its own, I could take away 60 on both sides. I'm balancing it. And that way, since over here it's going to cross out, I'm left with z equals 100 minus 60, which is 40. You knew that? Good, good. And over here, we've got x plus 5 equals 9. Again, I'm trying to figure out what x is, so I can take away 5 on this side to cancel these out, because 5 minus 5 is 0. Whatever I do on one side, I'm going to do on the other. My x comes down 9 minus 5, so x equals 4. 4 plus 5 equals 9, yep. 60 plus 40 equals 100, yep. Okay, so just remember that whenever you do something on one side of the equal sign, you need to do it on the other. And please remember, whatever I'm writing down, you are expected to have on your homework notes as well. Okay, so that's just a good reminder. Whenever you do an operation on one side of the equal sign, you must do it on the other side. All right, so I'm going to move on. So I want to take a look at this with you and read through it, kind of highlight, underline some important pieces of information. So follow along with me as I read this. You can use algebra to determine the fraction that is represented by the repeating decimal 0.44444444. Remember, the ... tells me that it's going to keep on going. First, write an equation by setting the decimal equal to a variable that will eventually represent the fraction. So the first step, all we're doing is we're just picking a letter, a variable, and we are setting it equal to our repeating decimal. That's all. So in this case, they picked W. If you, Caitlin, want to pick K, or if you, Maddie, which one, want to pick M, whatever the variable, that's fine. All right, next. Write another equation by multiplying both sides of the equation, both sides of the equal sign, by a power of 10. Now, this next part's really important, so I want you to underline it, because this is the part that's easy to mess up. The exponent on the power of 10 is equal to the number of decimal places until the decimal begins to repeat. Again, the exponent on the power of 10, so however many times I want to multiply by 10 or 100 or 1,000 is going to be equal to the number of decimal places until the decimal begins to repeat. Okay, so we're going to go through that in an example or two. In this case, with 0.44, the decimal begins repeating after just one decimal place, right? Because right after the decimal, there's a 4, and that's what's happening throughout, 4, 4, 4, 4, 4. So in this case, all I need to do is move my decimal one place over, which is the same thing as multiplying by 10, which is the same thing as multiplying by 10 to the first power. Okay? 10 is the exact same thing as 10 to the first power, and the reason I only need to multiply by 10 is because I just need to move my decimal point over however many times my number is repeating, or however many times where the decimal starts to repeat. And in this case, it starts right away, so I just need to move my decimal one place, which I know is like multiplying by 10. So all we do now is we multiply both sides by 10. W times 10 is 10W, and 0.44 times 10 is 4.4. Okay, now the dot, dot, dot tells me that these 4s are going and going and going and going. Then, subtract the first equation from the second equation. So my second equation is 10W equals 4.44444444. My first equation was W equals 0.444444444. So now all I'm doing is subtracting. 10W take away 1W is 9W. And 4.44 minus 0.44 leaves me with just a nice whole number 4. Well, now I've got a one-step equation. 9W equals 4. In order to get the W by itself, I can divide both sides by 9. 9 divided by 9 is 1. So I'm left with 1W is equal to 4 over 9. And I can leave it like that. Fraction in simplest terms. Okay, so recapping what we just did, we took a repeating decimal. We used algebra in order to figure out what this fraction equivalent is. So 4/9, if I were to put that in a calculator, I would get 0.44444 repeating. Okay, so we're going to give it a try now with this example. Let's try 0.55. More properly said, 55 hundredths, right? Here's my tenths place, here's my hundredths place. So this is 55 hundredths. All right. So the first thing I need to do is set this equal to a variable. I'm going to stick with W, but Carlos, if you want to use C, go for it. All right, so W is equal to 55 hundredths, and I know that this is repeating. The next thing I need to do is figure out how many times I should multiply by the power of 10 for however many times wherever this starts repeating. In this case, it starts right away because this is 5 repeated. So I need to just move my decimal one place. In other words, that's multiplying by 10. So I know now that if I multiply whatever I do on one side, I have to do on the other. So W times 10 is 10W. 0.55 times 10 is 5.5 ... And now if I want to get rid of my original equation because I don't want all these decimals anymore. And I know originally that W was equal to all those decimals. So I'm going to take away a W from both sides. Whatever I do on one side, I have to do on the other. 10W minus 1W is 9W. 5.5555 minus W was 0.5555 leaves me with just good old 5. Right? Because W is equal to 0.5555. It's all those decimals. And I want to get rid of all those decimals. Now I have a nice pretty one-step equation. I can divide both sides by 9. in order to be left with 1W equals 5/9. Therefore, 5/9 is the same exact thing. It's just a different form of 0.55555 repeated. Now let's take a look at a little bit different example. This one is a little bit different, and we'll talk about why as we go through it. So, if we are given the repeated decimal 0.09, and if it has a line over it that tells me 09 repeats and repeats and repeats, I need to first set my repeating decimal equal to a variable. This time I'll switch it up. Okay, I heard you complaining out there. X equals 0.090909, but I don't need to write all that because I'm going to get tired, so that's why we just use that one little bar. Okay, so if W is equal to 0.09 repeating, I now want to multiply by a power of 10. So I need to multiply by the power of 10 until, for as much as my decimal was repeating. In this case, the 0.9 is the repeated part. So I need to move my decimal enough to get me through the part that's repeating. So am I only moving one decimal place here? No. I need to move 2 decimal places. I need to get all the way past where it's repeating. Remember the original, 0.09. 0.09. So this would be, this would be 10 to the first. So this must be 10 to the second, or 10 squared, or 100. So 100x, whatever I do on one side, I do to the other. If I multiply this side by 100, I need to multiply this side by 100. 100x is really the same thing as 9.09. Now I'm going to do the same process as before. I want to get rid of all this decimal junk. So I know the decimal junk is x, so I need to get rid of an x on both sides. 100x, take away 1x, is 99x. Very good. 9.09 minus x, which is 0.09. So 9.09 minus 0.09, well, that's just 9. So did I accomplish my task of getting rid of all the decimal junk? Yes, I did. Hi, Chair. So now I have a one-step equation. I'm going to divide both sides by 99 so that I can get x by itself. 99 divided by 99, that's just 1x. 9 over 99, can I simplify that? Very good, both of them divide by 9. 9 divided by 9 is 1. 99 divided by 9 is